Um, okay. Does anybody have any issue with the installation?
From my side, it's okay. No issues.
Installation is okay, but can you give a little intro with the commands that we were having those video in that video? Can you?
Sorry, you said something. You said, can I what?
Yeah, I'm okay with the installation, but can you give the little intro about the commands that were in the video?
All right, I didn't hear you well. Sorry.
Installation part was okay, but little bit if it will be better if you can give a little intro to the commands like dashboard.
Okay, that's so I want to do the installation too on my side, and then we'll go into the commands.
Okay.
Okay.
Yeah. All right. Can you see my screen?
Yes.
Yes.
All right. So what we will do today is I'm going to install my own, okay, and then we'll start looking at those commands that we talked about during the theoretical part of the course. So I'll run through my installation because I don't have it installed in my own operating system. This is a fresh OS I have.
Okay.
So installation is complete. And the next thing we'll do is to start looking at those commands. So the first thing you need to take note of is, please can you hear me?
Yes, yes.
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 Right. So there are a couple of things you need to take note of here before we start. Now, the command we are working with is called kubectl. Okay? But for some reason, we don't have kubectl in this machine. The reason being that microk8 doesn't use kubectl. It has its own command line. It's the same thing, but the syntax is just a bit different. So it's microk8.kubectl. Okay, you can see the command works. So it's the same thing with kubectl. If you even look at the usage and everything, but they kind of created a separate binary file for it. I don't know if it makes sense. So just understand that it's the same command, even if you're in a production environment, anywhere, kubectl is kubectl, but the command is microk8 or kubectl because we are using microk8. That's just the difference. Are we clear on that part?
Okay.
All right. So let's start looking at some of the commands we talked about from the beginning. So the first command we talked about was we talked about a lot of commands, but I will start it from a standpoint and we'll graduate them into other commands. So the first thing you need to take note of is we talked about the pattern of the Kubernetes command, and we talked about certain components that make up Kubernetes. So we'll start from the smallest units of a Kubernetes cluster, which is what we call a pod. Okay, a pod is where your application is running, and so on and so forth. So we will try to create a pod. Okay, but before I go further to create a pod, let me try and view some of the components that we talked about. And to view a component, we use the command called kubectl. Okay, the operation, the resource, right? Do you remember that? Are we there?
Yes.
So the first command we will do is to try and view some of the resources that we talked about. We talked about pods, we talked about services, we talked about deployments, just to get our hands warmed up first of all. So to view any of the resources, we use the command, like I said, microk8 view pods. Okay, sorry, not view, get, sorry. So do you see that there is no resource found in the default namespace? Now, if you remember in the class, I talked about namespaces, and I said namespaces is a method of logically separating components in Kubernetes. So if you want to separate different components in Kubernetes cluster, you use what you call your namespaces. And I also explained to us that in certain environments, in certain setup, namespaces are used to differentiate dev, staging from production environment. So it creates a layer or a boundary between the three environments. Now, you might have your pods in any of the nodes within the cluster, but within Kubernetes itself, it creates its own network layer, it creates its own pod configuration that makes each environment unique within a namespace, up to the level that pods within a namespace and another namespace cannot communicate with each other. So what this command is saying is that there are no resources found in the default namespace. Now let's see the namespaces we have in this machine. What do we use? The same command. Microk8 get namespaces. So how many namespaces did we find there? We found about 4 namespaces, right? Are we together?
Yes, yes.
All right. So what if we want to create a namespace? Can somebody help me with the command to create a new namespace based on what we learned in the previous class?
Can you repeat what you are asking?
I said, can somebody give me the command to create a namespace based on what we learned in the previous class?
One second.
Anybody?
kubectl create namespace, then namespace that we want to define.
Sorry, say the command again.
Maybe microcreate dot kubectl create namespace, create namespace, then we can see the development production where one to define.
Okay. All right. Thank you very much. That was easy. Can we see it's created? So how do we view the namespace we created? We use the same command, get namespaces, and you can see the namespace has been created.
Okay.
Any questions on that?
No.
Fine.
All right. So this is just a pattern that we are going to continue to, repeat across board. There's really nothing else in Kubernetes so much, but understanding these components and each of the architectures is actually what matters most than every other thing. So let us go a bit deeper and start looking at other components. So if you want to delete this namespace too, we do the same command. Delete namespace, and it's gone. Do you see that? So when I do get namespaces, you can see it's gone. Can we see that?
Yes.
So you can create a namespace for dev, you can create a namespace for staging, you can create a namespace for production, and deploy your application on these individual namespaces.
So every other resource that will be created, we create, then we need to pass the namespace flag along with that value in every command, like we are
Yes.
creating a
Okay. Exactly. So when you are creating a pod, for example, you put the namespace flag so that it creates that pod within that namespace.
Okay.
Okay.
So what we'll do next is to try to create the namespace again, and let's see how we can deploy to that namespace. Sorry, excuse me. Sorry about that break. Okay, so I was talking about trying to create a namespace. And after creating a namespace, we deploy into that namespace. So let's create a new namespace. We say we call it dev. What did I miss?
Names.
Okay. So let's try to deploy a pod. Okay. So for this example, we'll be using Nginx, but I suggest that when we are done with this course, one of this class, your assignment will be to use your own Docker image that you have built. I remember I told us to build a Docker image and push the Docker hub, right? Hope we're able to do that.
Okay.
So I want us to try and deploy our own Docker image using this same thing. It's pretty straightforward. If you have any questions, you can always ask me. Okay, so with this command I just wrote now, I just deployed a pod. Can we see that command?
Yes.
So that image tag, that image is to specify the image I want to put in. Now, the reason it's so straightforward is because this image is a Docker image that is in Docker Hub without any form of authentication or authorization. So I can easily put it without any form of restriction or security. Okay?
Okay.
So how do we verify that the pod is actually running? So we do the same microkate kubectl get pod. Can we see the pod is running?
Yeah.
It will be in default namespace.
Exactly. I deployed it in the default namespace. So let's try and deploy it in our development namespace that we created. Okay?
Okay.
All right. So let's do that. The same command. I can specify the namespace and call it, what did I call it? Development, right? No, dev. Yeah. So with that flag, okay, we are supposed to have two namespace, two pods here, right?
Yes. In different
But
namespace.
sorry?
Yeah, two pods, but in different namespace running.
Exactly. So if I do get pods here, you're going to see only one namespace, only one pod running. So view, get pods. You can see only one pod is running in this namespace. But the question is, how do you check what's going on in other namespaces? Okay, that's where the flag also comes in. We use the namespace flag and say namespace dev, and that's it. So you see the difference between both of them is this is has 119 seconds of age, this is 52 seconds of age. It will make us know that this is older than this other container. Does that make sense to us?
Yes.
Yes.
So I just said kubectl run pod. Okay, it can be any name. So let me quickly delete it and just use another name for it. Cube microkate dot kubectl delete pod. Now I'm saying delete pod because pod is the name of the pod. Do you understand?
Okay.
So if I can verify if that pod still exists by doing get pods. And voila. Don't forget we are in the default namespace. But if I do namespace equals dev, you still see the other pod is still running. Can you see that?
Yes.
So let's try and run this pod using another name, basically, just to show you can actually name the pod. Okay. Don't forget, this is an image name. It could be any image. I just choose to use Nginx. So you can see that I renamed the pod to Nginx pod. So if I do locate, keeps it here, get pods.
Yes.
You're going to see that it's used. So do we have any questions on that?
All good.
Oh, good. All right. Awesome. So there's the name of your pod actually doesn't really matter. Forget that I wrote Nginx pod. It can be any name actually. So don't really worry about it. You can see I gave it my app. You can call it NOps. You understand? So I mean, it can be anything. Okay, so please don't think that you actually have to use pod at the end of the name. Okay, I just want us to have that at the back of our mind. And then there are shortcuts. If you can look very well, you can see I'm using a shortcut here. Yeah, you can see I use the shortcut here. So you don't really have to say get pods. You can say get PO. Okay, it's still the same thing as pods. Same for the namespace. You can say get NS. These are just shortcut commands that can make you, get around a bit easier and faster. So we have three pods running at the moment within this namespace. It's quite different from the other namespace. So we've been able to, create a namespace. We deployed our pod in a particular namespace, different from the default namespace, and we deleted the pod from the default namespace. And we could also see that it doesn't exist. Sorry, the pod in the other namespace, which is the development namespace, still exists on its own. So that shows you that there is a line that draws between, there's a boundary between each namespace, like there are different entities on their own. Are we clear?
Can you please repeat?
What I said was that we're able to create a pod in a particular namespace, which is the default namespace, without any flag. And we also created another pod in a development namespace, which is a unique namespace we already agreed on. So when we did that, we deleted the pod from the default namespace, and we discovered that the pod in the other namespace still exists. So that explains clearly that both of them are very separate entities. When you create 5 namespaces and you deploy pods across them, there are 5 different pods on 5 different namespaces.
Okay. That we have namespaces and same name. If we have same name, then we have 5 different pods.
So I didn't get that.
Yes. Okay.
I didn't get what you said. Can you repeat that? Hello?
Prashant, can you repeat? He's asking what you're asking.
I think Prashant meant that we have a different port has like for particular names. It's like, for example, we have a port for development, which is absolutely different from another namespace like default. So we have 2 different identities.
Yeah. It's correct, but I want us to see it in the perspective of what is actually different is the namespace, not really the pod. Okay,
Right.
it's just
Right.
like exactly different houses with, you can have an estate of the same house, you understand, but different people living inside of it. But here we're talking about different houses. Okay, so the same people can live in, you understand, the same people can live in different houses. So it can be the same pod, but you want it in staging namespace. It's the same pod, you want it in production namespace, just to create a clear line of difference. But in the end, your pods are still going to be in the same node. Your pods can be on the same node, so that's where it becomes a little bit tricky. So you might decide to say you want to use a single Kubernetes cluster and have staging and production. Okay, within Kubernetes, you create 2 namespaces. Okay, and then you deploy your pods in staging namespace and production namespace. In the back, actually, your image or your container is actually deployed. 2 containers or 2 pods can actually reside on the same node, okay, which could be dangerous. So it's always advisable to not use namespaces so much when you are working in production environment. Maybe for staging and test, but for production, you need to use something else we call node affinity, okay? What node affinity does for you is that node affinity ensures that you can specify the node you want a particular pod to deploy to and the namespace to deploy to. So with that in mind, it means that you can have multiple nodes in your cluster and ensure that some pods that are production deployment do not go to the staging. Because if anything happens to the staging environment, it's going to affect both staging and production, which is not a very good design.
Okay.
Okay.
Any questions? Any questions?
No, I think we can move forward.
All right. All right, so let's move on. Now we talked about another important component of Kubernetes called the service. Now, if you remember very well, we talked about the service being what exposes a particular pod for access. Okay. Now, without a service, your pod is practically not accessible over the network. So you need to create a way to be able to access that particular pod, and that's where the service comes in. Now, what the service layer does, the service is just like a web server, okay? Just imagine that you have a web server in front of your application. Say you build a Node.js application or you build a Python application. Even if you have your Python application in the server, you still need a web server that will receive the requests and then proxy it over to the application, right? So the same way the service layer in Kubernetes stands between the traffic coming in and the pod. So the pod we have running right now is a pod, beautiful, fine. But at the moment, we cannot send traffic to the pod. Okay? So we need to create a service layer that will allow that pod to receive traffic. Am I making sense?
In simple terms,
Okay.
we can say that it helps to communicate between two pods, right?
Yes,
Services.
yes. It serves as a service layer, and it also does load balancing. So let me explain how it does load balancing. We're going to talk about replica sets very soon, which is having multiple pods within a node. There's still going to be a service layer that needs to route traffic across all these pods. And it's the beautiful thing about Kubernetes is it's the same service that you created from the beginning that you are still going to use for the pods. So you're not like creating a service for each pod, a service for each pod. No, a single service. Even if you have 100 pods in your cluster, 70 pods in your cluster, you are still going to be using a single service layer to communicate across all the pods. So in that vein, you can see a pod, a service, as being a load balancer within the cluster. Good?
Sorry, but I missed the last part.
No, what I said is that I said within a Kubernetes cluster, your service acts as a web server and a load balancer. A web server, if you have a single pod, it receives traffic and routes to that pod. But if you have multiple pods, it is the job of the service layer to route the traffic across all the pods within that cluster. So if you have 50 pods, 100 pods, you don't need to create another service layer to communicate with the other pods. The same service you created will be able to communicate with all the pods within that cluster.
Okay, so basically it's a default behavior of the Kubernetes to route the traffic from one pod to or multiple pods.
Yeah, it's actually the default behavior. You don't need to configure or touch anything for that to work.
Okay. Okay.
So the service is intelligent enough to know when it has multiple pods and a single pod. Another beautiful thing about the service is, okay, that's not from the service layer, the pod layer. You can actually know if a pod is down. Okay, I think it's from the service layer. So if for any reason you have, let's assume you have 3 pods running, okay, you want to maintain high availability for your application, and something happens to a single pod, what happens is that that service layer does not route traffic to that pod. Okay, it looks for any of the pods that are healthy to send the traffic to until that pod is available before it starts routing traffic to that pod.
Okay.
Am I making sense?
Yes.
Yes.
Thank you. Okay. Let's see. Okay. So let's take a look at the command I just typed now. So the command is trying to expose the pod called nops. Can you see that? Expose pod nops, and then the type. So I'm going to talk about, before we move on, I'm going to talk about the types of services we have in Kubernetes. Kubernetes has different types of services. Okay?
Okay.
Now the first service we have here is what we call the node pods. the node port is a kind of service that exposes your pod, okay, with a port within the node. It exposes your service with a port within the node. What it means is if you build an application, say you are using port 4040, okay? Now, when you deploy the pod, that application is not available to anybody. Now, you need to create a service layer for that pod. And if you specify node ports as a service layer, okay, and you configure port 4040 for that node, it means that it is only on that node that you can actually hit that particular service. So you need to do the IP address of the node and port 4040. Should I go over that again? Hello?
So here the port flag is the node port we will define, where the
Yes.
service is mapped to.
Yes.
So basically using node port, we are exposing container port 80 to host 80 port, right? Something like that.
Exactly.
Okay.
Make sense?
Yes.
All right. Let's move to the next one called the cross.
Mention the container port.
Yeah, so most of the time, so if you notice when I wrote the command the first time, it said could not find port via port flag. Now, because I did not specify a container port, it's forcing me to specify a service port. If I had specified a container port when I was doing this command here, it would have taken that port to expose itself.
Oh.
Does it make sense?
Oh.
Exactly. So I did not specify a port, so my service is not even exposed at the moment. So even with this service layer, you still cannot hit my containers, my ports, because my containers and ports do not have a service layer, sorry, a port that I have exposed. Does it make sense?
Yes.
Yes.
Exactly. So you need to have put a port for your pod. And that port should also be the same thing for your service layer, so that your service layer will forward the request to the port. Because if your service is port 8020 and your pod is port 4030, there's going to be a problem. You might not be able to send traffic to that pod.
So while creating this service, we can also mention that container port via flag.
Yes.
Okay. Will it be a target port?
So yes, it will be a target port. Yes. Because it is a target for the service, where the service is going to route the request to.
Okay.
Am I making sense?
Sachin is taking to the another level. Target port is he didn't tell us about target port yet.
Yeah, I'm trying to take it one step at a time. I don't want to be in a hurry.
No, not a problem.
We'll get there actually. We'll get there.
Okay.
Okay?
Sure.
We're just talking about the command line. There's this YAML part. Okay? That's the real deal, actually. Okay? We'll sit down and look at the YAML template. I will explain the YAML template to us. We'll understand it, then we'll apply it. So I'm not trying to take us one step at a time. Okay? Someone is trying to rush us. Who's that person? Sachin, I guess you are the one.
No. While I was going through the installation, I was reading few of the commands given on this page. So that's why I was reading the whole article of micro-create. So that's why I came to know. That's why I discussed.
I see. Okay, cool. All right, we'll get there.
Okay.
All right. So the next thing I want to talk about is another service type called your cluster IP. Now, the cluster IP is unique in such a way that it's more or less gives all your it's instead of the node port that gives every node a port to access this pod on, it gives all the pods a single IP. Okay, so if you have 10 pods, all of them can be accessed with a single IP address. Okay, I don't know if you guys are getting the difference here. For the node pods, each node, okay, that has your pod running will have a port. We use the IP address of the node and the port specified. IP address of the node and the port is specified. That's why it's called node port. But cluster IP is that it's a single IP for the full, every single pod in that cluster. So if you call that IP, it's going to hit the service, which is able to route it to wherever the pod exists within that cluster.
Sorry, but I didn't get the last part. How can you fetch all the IPs?
Yeah, it's cluster IP I was talking about. Any confusion?
Can you repeat the last part again, please?
Sorry?
Can you repeat the last part? I missed that. I skipped that.
Okay, I was talking about the cluster IP. The cluster IP creates a single IP address that gives you access to all the pods within your cluster. Now, unlike the node port is actually giving the IP and the port for every service. So what it means is that if I create a node port, what it means is that if I have 3 nodes in my cluster, for example, okay, say 1.1.1, 2.2.2, 3.3.3, those are the 3 nodes in my cluster. If I create a service as a node port, what is going to happen is for each of the machines, okay, if I'm going to access my pod or my application, I need to do 1.1.1 column 2020 or 2.2.2 column 2020 or 3.3.3 column 2020. So every single node will have the same port to access that application. That's node port. Am I making sense now? But for cluster IP, instead of taking note of the nodes, cluster IP has no business with the nodes. It generates an IP address. That IP address automatically binds to all the pods in that cluster, all the nodes and the pods in that cluster. So if you want to communicate with the nodes, with the pods in that cluster, you call that IP address. The service layer automatically finds a way to route it to the appropriate service. Sorry, the appropriate pod within that cluster. Is that clearer now?
Can you show us some example?
I don't know how the example will help, because how do you prefer the example? Do you want me to but do you understand the node port concept first of all? I guess it's a cluster IP that's causing some confusion.
Yeah.
Okay. I'll come back to it, but let me just show us a couple of things. I'll come back to it now. We just created a service now, so let's get service. Can you see the service that was created now?
A node port you have created, its IP is this.
Yeah. Now you can see we're using node ports here. It creates an internal IP address, but it's for its own use. Now I'm going to create the service again and use cluster IP. Was still asking me for ports, okay? Sorry, I'm going to use my shortcut. Can you see that this created an IP for us? Okay. Now, on this level, we have 2 ports. Can you see that? But here we just have a single port. So it means that this port 80 is exposed within this machine and any other node within this cluster. So if I'm going to access this service in this cluster, I need the IP of this host machine and this port to access this pod. But for cluster IP, all I need is just this IP address, and that's all.
Okay.
Now, if I go to node 2, if I'm going to access this same service, I need the IP address of that node and this port again to access this service. For the cluster IP, I don't care which node I'm in. I can use this IP to access the service anywhere. That's why it's called the cluster IP.
Based on any of the nodes.
Exactly. Does it make more sense now?
Yes.
Now, the last service type I want to talk about is what we call the load balancer service type. Now, the load balancer service type is one of the most interesting. The funny thing about the load balancer service type is that it actually is very, very tied to cloud computing. Now, without a cloud provider, the load balancer service type does not function. Why? The reason is because it creates an external load balancer for your pods. So what it does is that on the underground, let me explain what happens. The first thing the load balancer does is that it creates a cluster IP. Okay? After creating your pod, it creates a cluster IP. Then it creates an external load balancer. In AWS, you can choose between classic or, okay, at the moment, you can actually choose between classic, network, or application. Previously, it was just classic and application, but now you can use a network load balancer. So you can use any of the network load balancers. It then proxies the request over to the cluster IP because it's actually the cluster IP that can now communicate with the pods. So with the load balancer, you have an external entry point to your cluster. Now, before load balancer, the node port and the cluster IP are not accessible outside of the node or the cluster. So before you send a request or make an API call to a service in Kubernetes, you must be within that particular cluster. So all these things I'm trying to explain to us, this node port, cluster IP, if you try to call this IP now, it's going to fail because Kubernetes does not allow you to communicate with services directly. So what people do before load balancers is that they create a web server, okay, maybe an Nginx or an Apache, that eventually proxies into the cluster. So if you remember in AWS, when we talk about private subnet, your private subnet does not have access to the internet. So you cannot send a request to your private subnet directly. You need something like maybe a bastion host. You need something like a proxy that will stand between the request coming in and where it's going to. So before load balancers that came from cloud providers, when you set up a Kubernetes cluster, okay, you create all your service layers, your node pod cluster, depending on what you want to use. You still need a web server or an API gateway in some instances. People use API gateways to receive the request and then proxy into the cluster, because you cannot call a Kubernetes cluster service or pod outside of the cluster. You must be within the cluster. But the load balancer concept, which is another service type, helps and allows you to make a request directly to the load balancer, which eventually proxies the request into the cluster or into the service and then to the pod. Does that make sense to us?
Load balancer just diverts the outside traffic to the clusters or the our ports.
So I didn't get that.
Yes. Just the load balancer service diverts the outside traffic towards to the service and then to the port.
Exactly. But before you use load balancers at the moment, your cluster must be in a cloud environment. So it's either you are in AWS or in Azure, you are in Google Cloud. You must be within a cloud environment, basically. That's when you can use the load balancer type. But there are people who have created certain custom configurations that allows you to create a load balancer locally, even without being in a cloud environment. We clear?
Okay.
Any questions on that? Any questions? Can I move forward?
Okay.
No.
No, I cannot move forward, or no, there are no questions.
Yes, you can move forward.
Okay, thank you. All right, so that's it about services, basically. We want to create a service. We want to create a service out of our pod and see how it works. We want to identify the 3 types of services and what they mean and how they relate. I'll just show us a couple of other components of Kubernetes. Then we'll move straight into using the YAML definition. Is that okay?
Okay.
All right. So there's another component we call the secrets. Okay, and if you remember very well, I talked about secrets being where you store sensitive information or credentials. Just like every other service, you have micro-K8, kubectl, get secrets. Okay, and hey, there's a secret that has been created here already by default. Now, apart from storing application credentials, okay, the secrets is very, very important when you are working with custom registries. What do I mean by custom registries? Okay, let me not say custom registries. Let me say registries that require authentication and authorization. For example, we are working with Docker Hub, okay, that it's a public repository. If you're working with, say, an Amazon ECR, okay, or an Azure ACR, or your Docker Hub has credentials, then you can no longer you can no longer deploy the normal way. You need to configure those credentials within Kubernetes so that Kubernetes can actually authenticate to those credentials before pulling that image. Now, Kubernetes needed a more secure way to store those credentials, hence the secrets. Okay.
Okay.
So the secrets are very important because, like I said, apart from credentials, when you're using a private repository, you need to store the credentials there. So just the way you create every other, component in Kubernetes, the same way to you create your secrets. It's not very different from the normal method. But let's just create a little secret and just to see how it's done. Excuse me. That's the name of the secret. Micro. I always forget that. Oh, right. Let's check the secret that we just created. How see the secret we created?
Okay. Can we create a secret for like a Docker hub for our particular account? So we don't have to
Sorry?
use. Can we
Can
also
you create
create a
secret for?
secret for Docker hub account?
Yes, you can. Yes, you can. But it's actually valuable when you are trying to pull, okay, from a private repository. Because when you are pulling from a private repository, you need authentication and authorization. Okay, but at the moment you are using a free Docker Hub account, so you might not really need to create that. Are we good?
Okay. So just wanted to know in the command, what is this generic means?
Yeah, so like I said, you can, there are different, okay, I didn't really talk much about the different kinds of secrets, but I already mentioned that you can use secrets in, apart from just storing credentials, okay? You can also use secrets for storing your registry credentials. That means if you're trying to use a private repository, okay, that is different from your normal repository. Now we are creating that kind of registry. You use a different type of secret for it, but it's still a secret all the same.
Okay.
Yeah. Any questions? I'm sure we are clear now.
Yes.
All right. So there are so many components. I can actually go on. We have something else called your we talked about okay, we talked about namespace, we talked about set, talked about pod. Okay, I'm going to talk about one more thing, then it will lead us to the YAML configuration, which is what we call a deployment. Okay, now a deployment is actually a component that is used to house other components or any other components per se. Now, a deployment in actual sense houses your pod, your service, your secrets, and almost every other component. The whole idea of that is it bonds everything into a single component. So if you want to make any change, when you apply that change, it has a direct effect on that particular deployment component. Now, this is very this is very, very crucial when working with replicas and replica sets. Replica and replica sets don't work in isolation. They must be within a deployment. Now, I purposely left this deployment, these pods running because I want to use it to demonstrate something to us about the importance of having deployments. So at the moment, we don't have any deployments, but just know that a deployment is a component that is used to house different components, pods, secrets, services. So you can have everything within a single pod. It's within a single deployment, and everything is controlled in that deployment. So you delete that deployment, it will delete the service, it will delete the secret, it will delete the pod, and any other component that comes with it. So it makes it easy for you to manage your application. So if, for example, you have 18 microservices, you can have 18 deployment files, and that deployment file contains all the components that is needed for that particular deployment or that microservice. Am I making sense?
Yes.
So that will lead us to the YAML method of deployment. Okay, now all we've been doing since we've been working with the command line, the CLI for deployment, but in actual sense, it is not scalable in any way, not scalable.
Is the deployment is not scalable once has been created?
No, sorry?
What is not scalable? Can you repeat that?
I said we've been working with the CLI commands for deployments. We deploy the pod, we deploy the service, but it's not a scalable way for administering and working with a Kubernetes cluster.
Okay.
So the most scalable way, or the most scalable approach, is to use the YAML configuration file, which is what we'll be looking at right away.
Okay.
So I want to reshare my screen. Can you see my screen?
Yes.
So this is another version of the same thing we did with the CLI kubectl command. Okay? We specify the pod, the kind is a pod, the name of the pod, the name of the container, and the image you want to run.
Okay.
So this is kind of a simple, straightforward task. Okay? So what we are going to do is we are going to run this on the same Kubernetes cluster and see how it works. Please, is the file very clear to us? I need us to respond. This is a very simple file. So it's just showing us the difference between this and what we ran before. What we ran before was kubectl, run my app and the image. Okay? But when it comes to the YAML configuration, this is how it looks like. Okay?
Okay.
So let's apply this to the cluster and see what happens. So I'm going to create a file. We use the vim command pod.yaml. So I'm naming this pod 1. I need to specify the container. Let's just verify that everything is correct. Everything looks correct. Do we see any mistakes? Any mistakes?
Looks okay.
Yeah.
All right. So I just saved it, and that's the file. Let's check it again, just to confirm. All right. So please, if this is your first time with YAML, please take note. The indentation is quite important. Okay, when you are writing YAML configuration files, it tells the difference between the file working or not. So let's take note of that. Okay. So how do we now deploy this into our cluster? We simply use the same kubectl, but this time we use the apply command. So let's do that. Microkit.kubectl apply -f or .yaml. You can see it's telling us pod 1 created, which is the name we actually called our pod. So let's see if it actually created the pod. Sorry. Can we see here? Now, there's another command that is very helpful when we are working with pods, deployment services, anything within Kubernetes, which is a describe command. If, for example, you are giving this cluster for the first time and you want to have some information, maybe you don't have access to the deployment file, you know the name of the image, you want to get information about the pod that was exposed and things like that. The describe file is very important in that scenario. So I'm going to use describe file to describe one of the pods that we have here. So microkit.kubectl describe pod 1. Now this will give us a lot of information about this pod. Can you see information? It's giving us the name. Sorry. It's giving us the name of the pod, the namespace it belongs to. Okay? Because, like I said, in the Kubernetes, in the production Kubernetes cluster, your pod can be in any node. Okay? So, but Kubernetes helps to manage how it distributes using the scheduler. Your pod to the required node it needs it to be scheduled on. Okay? The start time and dates. If there are any labels, what's the status of this pod? It's actually running. The pod has an IP address. Okay? And then the container. What's inside of the container? This is the container ID. This is the image of the container. A lot of very important information that can be very helpful. Okay, and then the events. The first thing that happens that the pod was created. It started the Nginx. It created the Nginx container and started the Nginx container. Okay, so successfully assigned the default to local. So this is where the scheduler. Can we see this message is coming from the scheduler?
Right.
Can you guys hear me?
Yes.
So the message is coming from the scheduler because it has gotten the required parameters to schedule this pod, and it has assigned this to this particular machine. And then the kubelet is the next to ensure that the image is pulled. Now it's trying to pull the image here because the image has been pulled. It's already showing us container image already present. If this was the first time we are deploying this image, you will see it's going to show us pulled image. Okay. Now it creates the container, it starts the container. So this even gives you a clearer explanation of what I was trying to talk about when I talked about the different functions of different components of the Kubernetes cluster. You can see the scheduler, you can see the kubelets working hand in hand. Any questions?
Seems fine.
Are we good? All right. So you can also describe a service too. Let me quickly show us how to describe a service before we move on. Sorry, that's my shortcut command for service. So I can say describe service. Let's take one service, NOPS SVC. So you can see, give me more information. What's the IP? What's the target port? See the target port that we were talking about before now. Can you guys see it?
Yes.
Exactly. The node ports, the selector. Now, this selector is a very, very important component. It is what determines which port is routing request to. Now, if you look at it, it's telling you run NOPS. And remember that we have a pod called NOPS, right? Do you remember?
Yes.
So with this selector, very important, it means that whatever traffic comes to this service is going to route the requests to this pod.
Okay.
Is there any questions? Are we good?
Okay.
Sorry?
Yes, we will.
All right. So being able to deploy using a simple pod. Well, in actual reality, we really don't deploy pods. What we apply are deployments, because deployments are what controls a lot of components that we can't control on our own. So that will lead us to the deployment file, which is a more elaborate file that contains more information. So I'm going to spend a little time looking at this deployment file. I don't know if you guys still have much time. I think we have done 1 hour, 30 minutes already. Do you still have much time?
I think we can continue in the next session if all
Yes.
Okay. All right. Because I know you guys usually want to stop at this time. So, like you have a meeting or so. Hello?
Yes.
All right. So we'll continue in the next class, right?
Yes.
All right. Thank you very much. Please, I'll just to see if we can, deploy our own images using the same setup and just create a service so we can look through it in the next class. Is that fine?
Absolutely.
Okay.
All right. Thank you very much.
Thank you for
Thanks. Thank you.
your time. Thank you.